We're talking here about physical versus chemical change. A physical change does not change what the substance is. It does not change the composition of a substance. I guess examples of this would be changes in the state of matter, either from solid to liquid, i.e. melting, or liquid to gas, i.e. vaporizing, of either two types, evaporation from the surface or boiling from throughout the liquid, but also turning gas into liquid, that's condensation, or turning liquid into solid, that's freezing. So as an example, if one were to vaporize water, it would take water molecules, which are kind of near each other, and then spread them out as a gas. So you can see it's all the same molecules here. Each one has one oxygen and two hydrogen atoms nearby, but they are just further apart, these molecules. Another example of physical change is dissolving. So let's say that you were to get some table sugar, C12H22O11, and sucrose, and you were to add that to water. So the water would surround each sucrose molecule, and the sucrose molecules would separate from each other. So now sucrose was close together with other sucroses, but now it's far apart and just surrounded by water molecules, as seen over here. Sucrose, table sugar, tastes sweet, whether it's solid on your tongue or dissolved in water. Dissolving doesn't change that it is sucrose. Similarly, dissolving table salt doesn't change what it is. Table salt tastes salty, whether it's solid on your tongue or whether it's salty water. So we also have chemical changes. These are changes where a substance turns into another substance by breaking or forming chemical bonds. Example, if you had a fuel cell in a car, which some cars now have, especially in California, instead of burning gasoline, instead of reacting gasoline, hydrocarbons, with oxygen, you might just have hydrogen reacting with oxygen. When that happens, you form water and release some energy as heat and also as work, propelling your car. So for example, there is a chemical bond holding these two oxygen atoms together. That is broken as also the chemical bond holding the two hydrogen atoms together is also broken. But then there's the formation of new hydrogen-oxygen chemical bonds instead. Breaking bonds and forming bonds leads to chemical change. So some clues of chemical change, you want to memorize these, are color change. That's one example. You'll find this occurring, for example, when leaves change color. Certain chemicals have certain colors. So if you have new colors, that means you have new chemicals. Similarly, certain chemicals have certain smells, odors, or tastes. So if there's an odor change, it means you have chemical change. An example would be rotting. There are new smells coming there because, for example, maybe some sulfur-containing amino acid might have been broken down into hydrogen sulfide. Now you smell it. Sulfur is particularly odorous. Fermentation is another example. Milk does taste different than cheese because new compounds are formed in cheese as it ferments. Also, when gas bubbles are formed, not when boiling, but just maybe upon mixing, that's a clue of chemical change. Also, when solid precipitate forms, so when some solid falls out of a liquid solution upon mixing, that's an example of chemical change. And finally, when light or heat or both are absorbed or released, that can be an example of chemical change. So example, fire releases light and heat. That's a chemical change. All right, thanks for watching.